Welcome back to Mr. Hassan's Maths channel. This is question number 7 from the January 2010 old C2 GCE Edexcel paper. And this is a topic which is in now P2, as it was in C2 before, basically about integration. The question here, number 7, first of all tells us that the curve C has equation y equals x squared minus 5x plus 4, and it cuts the x-axis at the points L and M, as we can see in figure 2. Find the coordinates of the point L and the point M. Okay, so basically where this curve cuts the x-axis is when y equals 0. When any function cuts the x-axis, you have to replace y equals 0 into that function, because when y equals 0, you're on the x-axis. That's the equation of the x-axis. So to find where it crosses the x-axis, you replace y with 0. So we can say at the x-axis, y is equal to 0. So we have to replace the y with 0. So you go x squared minus 5x plus 4 equals 0. So we need to factorize this. And we have two factors. Both of them will have x. Both of them will be negative inside the bracket, because you're going to have minus, and minus gives you plus. And the sum has to be negative 5, and their product has to be 4. Well, it has to be minus 4 and minus 1. So we can say that's when x equals 4 and x equals 1. So the coordinates of L and M, we can say the coordinate of L is 4, 0, and the coordinates of the other way around. You see L is the one that's closer to 0. So L is 1, 0. The coordinates of L is 1, 0, and the coordinates of M 4, 0. Okay, you can see L must be 1, 0, and M must be 4, 0. So we got the coordinates of L and M. And then part B, it says show that the point N 5, 4 lies on the line on the curve C. Okay, so the point N. Okay, now here's the equation of the curve, and here is the point. If this point lies on the curve, it satisfies the equation of the curve. So let's take x equals 5 and substitute it inside this function. If y comes out to be 4, then that means it satisfies the equation. X equals 5 as the input, y should become 4. This is like the input, this is like the output. So let's see what happens when we put 5 in here. You're going to have 5 squared minus 5 times 5 plus 4, which gives us 25 minus 25 plus 4, which is 0 plus 4, which is 4. So as when x equals 5, y equals 4, therefore the point 5, 4 is on C. Simple as that. Very simple little proof there. Okay, now we're going to go on to part C. Okay, now for part C, it says find the integral of this expression x squared minus 5x plus 4, which happens to be the same equation as the curve, but we need to find the integral of this. So to find the integral of this, what we need to do is we need to take the power and add 1 to the power and divide by the new power. So x cubed over 3 minus, then you're going to have 5 times x squared over 2 plus, then for the constant term, you just gains an x, and that's 4x, and then you have to have plus c, which is called the constant of integration, and there's the answer to that question. Doesn't need any simplification. That's it. So it's just that's the answer. X cubed over 3 minus 5x squared over 2 plus 4x plus c. Simple as that. Okay, that's part C. Now for part D, it says the finite region R is bounded by Ln. Okay, the line, this is a straight line Ln. Lm, which is the x-axis along where between the curve hits the x-axis, and the curve C as shown. Okay, so the curve C, this part of it. Use your answer to part C to find the exact value of the area of R. Okay, so we need to find the area of this region R. Now we got to use the answer to part C. Now part C is the integral of this curve, which if you take it as a definite integral, will tell you the area between the curve and the x-axis. Now we need to find this shaded area, which is the area above this line and above this curve between the line LN. So there's two things we need to do. Okay, we can think of it, let's look at the whole picture. What we can do first is we can think about finding the area of this triangle here. Okay, think of this as a right angle triangle. Okay, and this triangle has a height of 4 units because this is the y value of n, and it has a width between 1 and this value of n, which is 5. So the width between here and here is 4 units. Okay, 5 minus 1, this is 4, because this is the x value of L and this is x value of n, which is vertically above this point. So this area of this triangle, so you can say the area of the triangle is equal to a half times 4 times 4, which is going to be 8 square units. That's the area of that triangle. Okay, now what we need to do, let me just draw the triangle like this so that it's clear which triangle I'm looking at. Okay, if we can find the area between or under the curve between these two values, between 4, 0 and 5, 4, between 4, x equals 4 and x equals 5, the area of this shaded region here, if we can find that the area of that shaded region, then we would be able to find the, we can subtract that from the area of the triangle and we've got the shaded region. Okay, so that's what we're looking for, that shaded region. So if I take this small region here and find the area of that, take it away from the triangle, then I've got what I need. So I need to find the area of this small region here. Okay, so I can do that by finding the integral between the values of 4 and 5, okay, of the curve. All right, which we have already got all the information for in the last part of the question. So this is the equation of the curve that we have from before. So it's x squared minus 5x plus 4 dx. So we already found the integral of this, okay, which means not too much of a big deal to do again. It's x squared over 2 minus 5x squared, x squared over 3, not 2. X cubed over 2, x cubed over 3 minus 5x squared over 2 plus 4x. Now, when we've got a definite integral, we don't have to put in plus c. So that's the integral of that between these values. If I find that integral, that will give me the area under the curve. Take all that away from 8, and I've got the area of this shaded region. So now let's just put the values in. You're going to have 5 cubed over 3 minus 5 times 5 squared over 2 plus 4 times 5 minus, or bracket here, you're going to have 4 cubed over 3 minus 5 times 4 squared over 2 plus 4 times 4, and that should give us our answer. We can just stick this all in the calculator and get the answer here. We're going to have 5 cubed over 3 minus, this is, oops, minus, going to have 5 cubed over 2 plus 20 minus, and put in brackets, 4 cubed over 3 minus 5 times, let me just put this up here, 5 times 4 squared over 2 plus 16, 4 times 4. Close that bracket. That gives us 11 over 16. That's 11 over 6, 11 over 6, was it? 11 over 6. So that's the area of this small part here. So therefore the region R is going to be 8 minus 11 over 6, which is 6 8 is 48 over 6 minus 11 over 6, and 48 minus 11 is 37 over 6. Okay, so you're going to have 6 and 1/6 units squared. That's the area of R. The area of R is 6 and 1/6 square units. And there's the answer to part D, and that answers the question. So that answers the question here. Question 7 from the January 2010 C2 paper. Other questions from this paper. When I answer questions from this paper, these questions are normally the older question papers I answer by request. So I will put those questions together in the playlist for this paper over here. And in this playlist over here, I'll put questions that are to do with integration from P2. You can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.